In this video, we'll cover the problem valid perfect square. Here we're given a number, and we should return true if it is a perfect square, and false otherwise. So 16 is 4 squared, so we return true. The square root of 14 is not an integer, so we return false. We're not supposed to use any built-in libraries like square root. So what we're going to do is we're going to binary search. We know that the square root of the number must be at least 1, because they're telling us here the number will be at least 1. So we can binary search from 1 through the number and just try to find the square root. The difference between this problem and what we saw before, which is trying to find the square root of a number, is that in the previous problem, if the number is not a perfect square, we wanted to return the integer part of the square root. Here we just return false, in the case where it is not a square. The other thing to note is that there is only one right answer, right? Like there is one number that would potentially be the perfect square. There's nothing else. So we don't need to continuously be setting our variable, overwriting our variable like we've seen before. So let's go ahead and see this in action. So we'll start our left number at 1. Then we'll also have our right number, which is going to start at num. And we'll have, we don't need actually our variable to track any sort of index. So then we can say, well, left num less than or equal to right num. We want to do some work. So we're going to get the mid num, which is going to be get mid num, which will be left num, right num. We'll come up here and write that function, get mid num, takes in a left num and a right num. We're going to say find the distance between these 2 points, cut that in half, and add it to the left point. And that way we should reach the middle point. Minus left num divided by 2, return mid num. Okay. I'll also switch this to an e6 arrow function. Okay. Now here, what do we want to do? Well, we really care about the square of the number because we're kind of trying to find the square root, right? If mid num squared is equal to num, we know, hey, we found our answer. If mid num squared is too small, we need to search bigger numbers. And if mid num squared is too big, we need to search smaller numbers. So we'll grab mid num squared, which is going to be mid num times mid num. There are other ways to write this in JavaScript. I personally think this reads the best in terms of it looks like mid num squared to me. So I go with this. Okay, so now we can almost directly translate from what I said from English into code. So obviously if the mid num squared is equal to our num, then we know that we have found the square root, which is mid num, and thus this number is definitely a perfect square. So we return true. If mid num squared is too big, it's greater than the num, then we should be searching smaller numbers. So we're going to say grab our right num and move it to mid num minus 1. And the last case, I guess we can write else if here. It doesn't actually matter because mid num squared is not changing and it can only be one of these, but just so it reads a little bit better and is more explicit. Okay, if mid num squared is too small, we need to find larger numbers. So we'll say left num equals mid num plus 1. Now, if we break out of our loop, that means that our pointers crossed each other and we never found the square root. Therefore, we can return false as our default if we break out of the while loop. Let's see if this works. Okay, it passes that, and it passes on submission as well. Alright, well, that's all for this video, and thank you for watching.